compute the left Riemann sum for f of x is equal to x squared plus 1 over the interval -1 to 1 using 5 subdivisions. And so what we're going to do here, well, first of all, make a note that this is the approximation of the area under the curve x squared plus 1 between -1 and 1. And what we do is we kind of think of it as chopping it up into 5 segments and then doing an area estimation and just adding these areas up. Kind of. That's real rough. Well, first of all, notice how much does x change for between each subdivision. Well, it changes between 1 minus a -1, that's the difference of the endpoints on the interval, over n, which is 5. So in this case, we've got 1 plus 1 over 5, which is 2/5. So each little interval is of size 0.4. So if we go from -1 to 1, the interval endpoints are as follows. So the first one is -1, and then the second one is going to be -0.6, because you're just going to add the 0.4, and then what do we add 0.4 again, and you're at -0.2, oops, and then add 0.4 again, you're at +0.2, and then you're at +0.6, and then you're at 1. So those are the endpoints we're going to use when we go to calculate the Riemann sum. So let me move this all up. Okay, so now what we want is we're going to evaluate the function at each of these endpoints. So f of -1, and then we're going to add that to f of -0.6, add that to f of -0.2, add that to f of 0.2, add that to f of 0.6, and add that to f of 1. So if we calculate each of those into the x squared plus 1, so we have -1 squared plus 1, so that's 2. We're going to add that to -0.6 squared plus 1, sorry, that took me a long time, and that would be 1.36, and then you're going to add that to -0.2 squared plus 1, and that would be 1.04, and you're going to add that one to, let's see, we're up to positive, so 0.2 squared plus 1, and that's 1.04 again, because you just have the same thing. And then the last one is 0.6 squared plus 1, which is 1.36. And then we're going to add all of these up, and that's an estimate, and it's a rough estimate, but that's the estimate of the area underneath the curve. So the sum of that is 6.8. And so then in the problem you're given, you have a different equation, but I believe this example will be sufficient to follow.